So let's start. What is basically trie? Trie is also known as prefix tree or the digital tree. Is it like a tree like data structure used to store a dynamic set of strings where each node represent a character of a string? Okay, now let's say we are searching something. We are searching CA on Google, right? On Google we are searching CA. Now we are getting some suggestions, right? Let's say CAT, CAR, right, after the words, correct? So this is what here we will use trie data structure. This is basically the implementation of trie data structure, correct? So that's what are the key properties? Nodes store characters. Path from the root to the leaf represent words. Okay, so it support fast insertion, search and prefix matching. So let's see this example. Okay, this is basically the root. First one is root. Then let's say we are having the word cat, car, cart, do and dog, right? These are the words. Now you can see we are having the cat word from the root till the leaf node. This is cat, right? And we marked this last node as the end node. Okay, so how we will insert? First we will take this cat, we will insert C in the node, the character, right? After that A, we will add A, then T, we will add T, and this is the end node. So we will mark this as the end node, right? This is yellow, means this is the end node for the word. Now next word, car. So we will be using these C, A, the common nodes from the cat word. Okay, C, A will be common, then R is different. We will add new node, that is R. Okay, after this C, A, and we will mark this as the end node, correct? So adding nodes or character as nodes. Okay, mark last node as the end node basically, and thing like boolean will be there. We will make this true, correct? Now after that cart, we will be again using the same nodes that are common in the car, adding T at the end. This is the end node, so here cart is ended. Same with the dog, we will add D, O, and after that G using the common DO, correct? So this is basically the implementation of trie data structure. Understood? So this is what trie. After that, these are some real life use cases. Autocomplete. In the auto completion we will use this trie data structure. Spell checkers, IP routing. So these are some real life use cases. So now in the trie there mainly basis three basic operations. Okay, insert, search and start with. Okay, insert, we will be adding a word into the trie. Okay, let's say we are adding this cat, so this will be the insert function. Okay, search, now we are checking if a word is there or not. Okay, this will be the search. Start with, now we are checking some prefixes there if it's exist or not. Let's say we are checking for CA, so it will check CA is there or not. It's there, so we can say yes. Okay, so now the time complexity, we will check this later out. First let's see how we will insert, or before that how this node look like. Okay, let me clear this. Now we are having the root node, correct? After root node we are having this one subtree for the C character, right? Starting with C, one starting with D. Let's say we are having some word starting with A, we will be having different node for A, and for B, for C, for D, all of the 26 letters, correct? So we can say the root will have another 26 nodes, correct? So the trie node should have 26, or we can say array will be there, array of trie node, correct, of size 26 for each and every character. And after that, let's say we are at C, right? We are at C. Now again we will be having, for this node we will be having another 26 size array. Why? Let's say this is starting with A, the next one, this is car, right? Let's say we are having another word with B, anything will be there, right? And let's say T, something like this. So again there should be 26 words, right? So I can say for a tree node, every tree node there should be 26 size array of trie node, right? And what else? We will be having one checker. Let's say this is end or not, end is end. Let's say this is end of the word or not. This will be of type boolean. Got it? And when we will come to this T, we will make this is end true. That means our words end here. For this also, for this also, this is end will be true. For other nodes it will be false, right? So that we can know, like, from the starting till this point, this is one mode, one word, car, cat, cart, here do, dog, dog. So one and second thing. Understood? We will be having two things. First is array of tree node with size 26 for each and every character. Second thing is we will be having one checker as the character, the node is the end of the word or not. So now we are having this tree node. Okay, we are having this tree node. Now we need to insert it, right? We will start with the root. Start with the root. Let's check this step by step. Steps basically. Okay, we will start with the root. What is the second step? Second step is for each character ch in the word, calculate the index. So we will calculate the, basically we will traverse the first, start traversing the string, the word, right? And let's say for loop is there. After that, the third step, we will calculate the index for each word, index for each character, okay. We can simply do ch minus a. Okay, it will give the index in the form of 0, 1, 2, 3. That means for a, index will be 0 as we are minus subtracting it, right, the sky values. Then for 1 it will be b, it will be c, it will be d, right? Basically the 0 frequency array, the indexes we used in the frequency array, we are using the same thing, correct? So after that we are getting the index. What next? Calculate the index. It's done. If children, okay, now this is the children. Let's say this name is children, okay, this array name, right? Now we will check, let's say we are inserting C, so we will check this children of C, that is third index, second index, is null or not, right? If it's null, then we need to insert it, right? If this C is null, then we need to insert it. Okay, so check if children of what, the ch is equal to null, then insert it, insert it. Otherwise if it's there, move to the next node, that means we will move to the next node, correct? So create a new node and move to that child node, right? Got it? Let's dry run this one. Let's say we are inserting car, okay, nothing is there, or let's insert from here, root is there. And then for this we will be having one children, right? Children with 26 size of type trie node. Okay, it will be like this. If you see 26 size array will be there, right? Now we are inserting cat, right? So C 0 1 2, C will be here, right? So it will check if C is null or not. It's null. So we will initialize this with the new tree node. Okay, so again there will be 26 size array for the C, right? For the C, correct, right? We are in the for loop, so we will check the C. Okay, now node was here when we started. Now we will come to this node. Okay, the C, we initialize this, we inserted this. After that we are here. Now it will check for the second node, that is A. Again check it's there or not. It's not there, right? If it's there, no need to insert, just move to this node, right? So cat, we will insert it. Again it will be having next 26 children array, right? 26 child array. So what's next? It's T, right? So T will be something here, right? Again this will be having next 26 array, but this is the last node. Okay, so we will make this for this what was the variable? Is end. We will make this is end equal to true, because this is the last node of the word, right? Last character of the word, correct? Now let's say cat is added. We are adding CAR. Okay, we will start from the root node. We will go to this C, it's not null. We will go to next node. A is not, it's not null. Again we will go to next node. Next is R, it's null, right? So we will insert it, and then we will make this is end equal to true. Got it? And let's say we are adding dog now. Dog. Now for each word, like when we are inserting, we will start with the root node only. Okay, root node. Then we will check if D is there or not. It's not there, we will add it. D added in the same child array, right? The roots child array. After that, next is O. It will add O. It will be having another 26 size array, right? Because this is different node, C is different node, correct? So here O will be somewhat here, right? Next again it will be having next 26 size array, right? Now insert. Let's write the code for this. Here you understood the logic, the steps. Basically first we will start with the root node, then each character in the word we will iterate each characters. Shall we code this method? Insert. Okay, so this is the same question we are doing, right? In this we need to implement the try. Okay, so class try node. Here two things are there, right? These two things, node, and here also node. So this is basically the try node, correct? Now when we will start with the class, we will first make a root variable, try node root. Okay, and when we are starting with the object, it will call the constructor, right? So we will initialize this root. So root equal to new try node root. Correct. Then let's come to the insert function. What's an insert? We will start with the root. So try, let's take a dummy node for iteration equal to root, correct? So initially we will start with the root. What next? Now we will check the each and every character of this word. So character ch word dot to char array. Then what's next? Now we need to calculate the index, right? If you see here, we are starting with the root. For each character, calculate the index. Okay, so index equal to, how we will do, ch minus a, right? We will get the index according to the, basically on the basis of, basically we will get 0 based index. Okay, right? For a it will be 0, for b it will be 1, and so on. What next? Now we will check if node dot children is not null, then we need to initialize this. If children of this index, children of what, ch is equal to index is equal to null, then we need to do what? We need to initialize this, right? Node dot children of index equal to new try node. Correct? After that we will do what? We need to move to the current node, that is node equal to node dot children of index. Got it? And at the end, when we will traverse everything, all of the characters from the word, we will say the last word will be the last node, right? So for that we will say node dot isEnd equal to true. Understood, guys, what we are doing here? First we are starting with the root, correct? Starting with root node. After that we are checking the characters, traversing characters. After that we are checking, we are calculating the index, and it's a 0 based index as we are subtracting the ASCII value of 1. After that we are checking if this is null, that means the character is not there, right? So we will initialize a new try node for that index. Okay, again there will be 26 size array for this node. Okay, for the characters. Now we will be moving the node to the next. That means if we are adding C, then it should now pointing to the C for the next characters. Okay, because A is coming after C. Got it? So basically what is happening, if we are at root, okay, root, it's having basically 26 size array. It's adding C here, or initializing the new try node. Again it's having the 26 size array, right? After initializing this, our node from here, it should be here now, right? Because C is completed. Now we are at A should come after C, so node should be at C. So node dot children is this one, so we are adding A here, and same for the next. Understood, guys? At the last we will make this the last node equal to true, means this is the last node. This part is clear for everyone, right? The insert function, just we are adding the characters one by one and initializing the node for that. If it's already there, then we are just moving to that node and moving to the next character. What is the time complexity of this? So the time complexity will be OL, where L is the length of the word, okay, and the space will be, time will be of L, space will be O of N into L, where N is the number of what? Number of words, and L is the average size of the words. Okay, so insert is completed. Now we need to search for a word. How can we search? So searching for a word, how we will search? We will again start with the root node. For each character we will traverse the first part is start with root, the next step traverse the characters, and for each character check if this is null or not, right? For each character each character. First calculate the index. Okay, index we will get. After that we will check for each character if the value, what value, children of index, if this is equal to null, that means word is not there, right? We can say false. Correct, it's not present. Otherwise move to the next character or the child. Correct, right? So this is the step. Calculate the index. If children index equal to null, return false. Word not present, move to that child. Now node will be pointing to that child. After that, after the loop, check if the current node has is and equal to true. Now we need to check this. Okay, we are searching for whole word. So for the last element we need to check. Last element we need to check. What we need to check? If is and is true for this or not. If this is true, then only we will return true, otherwise false. It's just a prefix, not a full word. Okay, let's see the example. We are searching for CAR, right? We will start from the root node. Correct. Now we will go to the children of this, children of root, that is children of, what is the index of C? It's 2, right? So we will go to this node. It's not null. Okay, we will go to the next. Now node was pointing to this. Now node will point to this. Again it will check for the children. Node dot child. What is the index of A? It's 1, right? Again it will check. It's not null. Now node will be there. Again it will check the next character, that is R. What is the index of R? It's, I don't know, let's say X or anything. Let's say 16, I'm not sure. Okay, so it will check for the R. It's present. Yes, it's present. Now this is the last node, right? This is the last character. We will check is and is true for this or not. For this it's true, so we will return true. Correct, understood? Now let's say we are searching for CA. Word is CA, right? We will start with this root. We will check for the child. C is present. Yes, it's present. Node will be here now. Again it will check for the children. The size, the index is 1. It's present. Yes, it's present. Okay, now it will check. This is the last character, right? It will check is and is true for this or not. It's not, so we can say false. This is not the full word. This is a prefix. Understood? So this searching is clear for everyone, right? If it's clear, shall we code it? Okay, so let's code it. Search. Now we will again start with the root node. Try node will be root. Correct. After that, search for each and every character, traverse for each and every character, char ch of word dot to char array. Right. After this, we will calculate the index. It's same procedure, right? It's same as we did earlier. We are calculating the index, then we will check the same condition also. Index equal to ch minus a, right? After that we need to do what? We will check if node dot children of index is null or not. If it's null, return false. Okay, we can say this word is not there. Otherwise we will move to the next node. Node equal to node dot children index. Okay, so after this, at the end, we will check if this node is the end of the word or not. So we have this boolean. So we can check if node dot isn't it's true, return true, otherwise return false. Got it? This is the implementation of search function. It's almost same, just a few changes. We are returning false here. Understood, guys? So search is completed. Now we need to check prefix. Here what we are doing, we are checking for the full word. Now we are also having one function where we will be checking prefix. Okay, prefix, is this prefix is present or not. Let's say we are checking for the CA, right? Here we are returning false, but here we will be returning true. How can we do this? So here we will be having the same code, just the last condition will not be there. This condition will not be there. Clear for everyone? Here we will be checking for the prefix and the word also. Let me give you an example. Let's say we need to check for C only, right? We will start with C. Okay, root. Then we will check the C, it's present. We will move to the next node. A, it's present. Now A is the last node. Word are completed. So we can say return true. We are not checking this last condition. Okay, because we are not checking for the whole word. Just we need to check the prefix. Okay, it can be a whole word also. Let's say we are checking for the car, right? We are checking for car, so it will check for car also, and we will return true. We are not checking this is and equal to true or not. Understood? So that's it. We can try running this. Compilation error. Acha, prefix is there. Okay, it's accepted. So all of the methods are working. Insert, search, and starts with. So the time complexity will be of L overall, right? Time complexity will be of L, where L is the length of the word, and space complexity will be n into L, where n is the number of words, L is the length, average length. So now let's talk about this last function, that is suggestion, right? How can we get the suggestions? I think fourth function is get suggestions. Okay, let's say we are having CA. We typed CA. Now we should get the suggestions. What are the suggestions? Cat, car, cart. Correct? If we are typing D, then we should get the suggestion DO, DOG, right? How can we do this? Can we use DFS here? DFS or BFS? DFS, let's say DFS. Let's say we are at this, the last node of the given string. Then what? We will apply DFS. We will go and check each and every node. If the node is end equal to true, if for any node this variable is true, that means this is the valid word. We need to return it or save it in result. Correct? So for T, we will be getting the is and equal to true. We will add this word cat in the result. After that, we will be getting this R also, this T also, right? So now while inserting, we will do one more addition there. Like how we will get the word? How we will get the word? We are not storing the word, correct? So we can do what? While inserting it, we can just add the word also, right? So these are the steps for insertion, right? At the last step, we are doing what? We are marking the last node as is and true, right? After this, we will do one more thing. We will add result, add word. Okay, now adding word. Again, we need to modify our tree node. We are adding third thing here, that is string word, right? Means what? Now I am saying for every try node, we are having three things. First is children array of size 26, right? The second thing was is end, is the character is end, right? After that, I'm saying I'm also having string word, and this string word we will be only passing when isn't equal to true. Okay, storing the last word, storing the word at the last index, at the last character. Got it? Got it, guys? So we will be storing the word. Let's say we are here, right? When we are performing this last step as and equal to true, we will be storing the word also. Correct? The same word which we got in the input, right? After insertion, while we are checking here in the DFS, we are getting this node, we are checking this condition as and equal to true. If this is true, then we are getting the word, get the word, because for at this node our word will be there, right? Because this is the end node, the word will be there. One more thing should be there, we should get the word, because at the end we are returning the word only. Got it? How we are getting the word? So we can say these are the nodes, and at this node we have stored the word also. Word, that is what word? Cat. At this point we have stored car. At this point we have stored cat, right? Because for the try node we are having three things. What are the three things? 26 size array of try node type. Correct? The second thing is and the boolean value. Third thing is the word, string word, right? And this will be having values only at the last character. I hope now it's clear for all. Now I will be writing the code here only, but I can't compile it. Okay, so what we need to do, first we need to modify this try node. We will be having one more thing, that is string word, that will be empty initially. Okay, this will be having value only at the last character of the word, right? After that, what else we need to do? While insertion, while we are at the last character, we will do word equal to word. Correct? We will store the whole word at the last character node. Okay, now let's have the function. Okay, so let's say public, and we will be returning the, let's say, list. Okay, string get suggestion, and we will be having some value, string prefix, let's say the input, right? Let's say we are having CA. Correct? After that, first we need to check if these values are correct or not, right? So we can simply use this method, this line of code, right? Correct? If these characters are not there, so we can say this is not present, this prefix is not present, right? So return, what we need to return? New list, array list, right? After that, we will be having one result array, not integer, string result equal to new array list. Now we will start the DFS. In DFS, we will be passing the node, right? Because we need to start after this. Let's say we have confirmed this CA is there, then we need to start after A, right? So node then what else? We will be passing this result, right? Okay, and at the end return result, correct. Let's write the DFS function now. Let's say public void DFS. Within DFS we will be having one try node, correct, the node, then this result, that is list. What else? What we need to do? Base condition, if node equal to null, return from here, right? Otherwise we will check if this node is the end character of the string, right? Node is end. If this is the is end, then we will do what? Then we need to add this, right? Result dot add what? Node dot word. Here we are using this word which we have stored here, right? For every last character we will be having word value, correct? So we stored the word. After that, now we will check. Now what else? What we need to do? Earlier what we are doing? We are just traversing the characters and we are proceeding, right? But here we don't have the word. We will see for the node what we are having. For the node we are having this 26 size of try node, right? So we will traverse each and every character, okay, or the node, correct? So from A we will check each and every character. Let's say we will start from A, B, C, D, right? We will call the DFS for each and every character. So for loop int I equal to 0, I less than 26, I plus plus. DFS now we will be calling node dot children of index I, right? If it's null, then we will be returning from here only, right? If it's having the value, we will check if this is the last character of the word, we will add in the result. Otherwise we will check for the next characters. And what else? Result, correct, right? That's it. Yes. Okay, so that's it. Got it? How we are doing this DFS? We are traversing each and every node, each and every possible character. Got it, guys? What is the time complexity for this? Could you please explain car and camera? Car and camera for what? For which method? For suggestion or for this prefix one suggestion? Okay, let's create this. So we are having root, then we are having C, then A, right? Then R, then M, E, R, A. Let's say we are having this structure, right? We are having car and we are having camera, right? Now we need to check. We are given prefix CA, right? Prefix CA. Now we need to check. We need to return what? We need to return the suggestions. Okay, let's proceed. Okay, so we will check first these two characters, right? In the code, what we are doing, we are checking if these characters, the given string is valid or not, if they are present or not, right? If they are not present, then we are returning the empty list. Otherwise if they are present, we will be at A, right? Now we are at A, node is at A. Okay, now we will call the DFS. Okay, DFS, it will check for A, right? A is present, correct? A is present. Then what else? We need to check each and every character. For A, it will be having like this. Structure will be like this. 0, 1, 2, 3, and for R will be here. M will be here somewhat, right? So we will check each and every 26 nodes, right? For 0, it will be DFS for 0 to 26, right? For 0, it will be 0, right? It will be null basically for all of them. When we will come to this M, okay, we are at M now. This is not null, right? We are at here now. It will check if this is isn't, it's not the isn't. Again, it will check all 26 letters for this M, right? Here E is there, right? E is there, so it will call for E. Again, node will be this one. Again, it will call for all 26 nodes. Everything will be null except R. Node will be here and node will be here. Now this is the last node. Here is and will be true and word will be there, right? So we will get the word from this node, that is camera. Add it in the result. Okay, added in the result. After that, it will go back. After that, it will be null. Go back, go back, go back, go back. Now we are at A. Okay, we are at A. We completed M. What's next? Again, it will go to R. It's not null. It will come to R. Okay, check for this node. The value is true. Isn't value is true, right? So it will be having the word. What is what? Car. So it will be added in the result. After that, everything will be null for this node, right? So go back. We can say DFS for A is completed. It will go back. So at the end, we will get this car and camera in the result. Understood? This is the for loop. This is the for loop. Time and space complexity for this one, DFS. See, what will be the time complexity? We are having this method, right? This method is taking what? We are having the for loop. So time for this will be of L. L is the length of the word, right? Again, what next? We are having this DFS. Now what is the time complexity of this DFS? It will be O M into what? K. What is M? M is the number of string, right? After that A. Let's say here we are having 2 strings, right? 2 strings. Let's say we are having multiple M strings, right? Let's say M strings are there after this. So it will be M into K. What is K? K is the average length of this M strings. So overall it will be OL plus OM into N. Got it, guys?